Hey guys, my name is László Leber. Welcome to my channel Coaching. Today I'm gonna show you that how you can use different rendering techniques like server-side rendering, client-side rendering, and static-side generation and incremental static regeneration. I will show you these rendering techniques based on the React framework. We will use a Node.js application. So let's get started. Okay, so I mentioned that I have several tutorials about server-side rendering itself on my YouTube channel. The latest one is the implement server-side rendering in React 18 using Pipeable Stream in Node.js, and the other one is the how to implement server-side rendering in React. This is a little bit old one, but still actual. So here's a very nice flowchart. It is starting from the point when the request is arriving to the server side. So we will check it out today as well. And also we will improve this React SSR Pipeable Stream example with caching mechanisms to improve our server-side rendering solution to an incremental static regeneration solution. Okay, so start with the client-side rendering technique. This is basically the traditional one, which is the default one, for example, in case of a single page application written in React. Here you can see a repository. You can find it under my video. In this repository you can find an application which is written in Node.js and contains a React application as well. The React application is inside the SSR client folder, and we have a Node.js application around it. But now inside the SSR client folder, the React application is a React application which was created with the Create React App tool. Install the dependencies of the project, please. And in case of the client-side rendering, we will only run the client application. Now I have several starting scripts here in the script section. The start client and build client is for the React application. We can run the React application alone without SSR, and this is the good one for us now to try out what happens if we run a single page application, the React application only. So when we run the React application from here, or we build it and we serve it through an HTTP server, then the client-side rendering will happen in your browser. So now, the first thing, because this project is already compatible with the SSR rendering, the server-side rendering, please go to the index.html and switch this hydrate root back to create root, because now we don't want to use the hydrate. It will be used by the server-side rendering, and run the client-side application with the npm run client command, npm run start client command. And on port 3008. Okay. I forgot the import. This is very, very important. Can import this one. Okay, and here is it. Here is our simple React application, and if we check the network, the main thing is that in the root div there is nothing, because this content was rendered by the JavaScript code inside your browser. So this is the client-side rendering, this is your browser, this is your client, and the JavaScript code was generating this content. So originally in the first request response, only this content was coming from the server, and this root div was not populated. You can see here we are rendering the app component, and this rendering is happening inside your browser. Okay, what's the problem with it? It's harder for the search engines to index your content. So when they are arriving to your homepage, for example, the content is not there. So indexing is very hard. So it's not very search engine compatible. This is the reason that it's highly recommended inside in case of single page applications, that if you would like to improve your search engine compatibility, then use a server-side rendering technique. Of course, there are some tricks without server-side rendering, but they are not very effective. Okay, now let's check out the server-side rendering, the next step. Before we describe it, please revert back your code to use the hydrate route, because we are using it for server-side rendering. So here in my example, I said that this diagram shows the flow from the point when the request arrived to the server side. So the first step during server-side rendering, which is recommended, that get all the data which is needed to render the current page. You know, the page is not static in most of the cases. You need data for the rendering. If you, for example, you can fetch a list of cars, and after the list of cars arriving, then you can iterate through the list and you can render the list elements, you know. So on the server side, you have to fetch the data, all the data that is needed to render the page. And it happens on the server side as well. So not the client is fetching the data rather than the server is fetching the data from another server service instance. So this is the first step. The API, the backend application using the database to be able to get the data and sending this data back to the server-side rendering application. And after that, the Node.js application can render the HTML on the server side. So basically it means that it will run the React application on the server side. We will get an HTML and we can send it back to the browser in the response. So when the first time the user opens your server-side rendered application in the browser, the first request will be made, you know. And after the server-side rendering happens on the server side, this request will send back the rendered HTML to your client. And in the browser, the browser executes the same React application on the client side now, and the state of the client application should be equal to the React application which is rendered on the server side. So it will continue the running of your React application from the point which was the final point on the server side, the final state. So you need to send the rendered HTML to the client side. You need to send the actual state of your application to the client side, and after that, when the React application will be running on inside your browser, hydration will happen. The hydration means that the React application will attach only the event handlers on your DOM elements, and it won't render the whole application again, because it got the HTML from the server side already, so rendering is not needed anymore. And after that, the page will be interactable by the user. So this is the basic flowchart of the server-side rendering, and we can check out our application now. So how is it implemented? So we have this server.js where we set up an Express application. This is a web application which is running on a specified port, now 3009. And I won't describe this in detail because I have the other tutorial where we basically writing this code from zero, step by step. So just the main things that here you can see that we are rendering our React application and we are sending it to the client through a pipeable stream. This pipeable stream is a brand new thing introduced in React 18. So I recommend to check out my tutorial about it. But the thing is that we are rendering our React component here. The React component is the app SSR. This is our main component, which contains the app component, and here we have a cards list component. But here you can see that inside Node.js we are rendering it, and we are sending the rendered HTML to the client side with a pipeable stream. Also, yes, the CSS is not part of our server-side rendering technique here, just the JS files. Before we can render this on the server side, we need to prepare the React application itself. So for example, where is it? In our index.js, we are using the hydrate route I mentioned, so to handle the hydration itself. And yeah, and also we are building the React application. It will be placed in the build static folder with the CSS and JavaScript files, and we are using these static files in the Node.js application for response, because this app SSR contains the whole HTML. This is rendered on the server side, and we have to place the CSS links here in the header, you know. So we are referencing these static CSS files, and also we have to reference the first the main JS. The main JS here. This is the bootstrap scripts, and the other JavaScript files will be injected automatically because we are using lazy loading to load our components dynamically. It will happen on the client side in the browser when the built JavaScript code executes in the browser as well. Okay, and now we need to talk about a little bit about the static site generation. With static site generation, the page fetches data once during build time. So it means that during build time we are generating all the contents. Static generated pages are very fast and perform well because all the pages are built beforehand. This technique is perfect for pages that use static content like sales pages or blogs, where we don't need to change the content of the page frequently. And if something changes, then we need to regenerate the static files, but it should happen rarely. So mostly you can use this inside in case of static contents. Of course, you can write logic that will render your React application during build time. So this whole rendering technique will be happen in build time, so getting the data and everything. A framework that is working like this is Gatsby. So you can generate the whole site with all the HTML for each path, and after that you can serve it through an HTTP server. Yes. And finally, the next rendering technique that I would like to talk about today is the incremental static regeneration. There are times when you want to use static site generation but also want to update the content regularly. And here we will extend this little server-side rendering application with caching mechanism. It means we will cache the rendered static HTML for each URL that the user opens, and if we find the generated content in our cache, then we will serve it. Otherwise, we will render the content on the server side, we will cache it and send it back to the client side. This is one thing, that we will cache the HTML. And other thing is that, okay, here we don't have an API, but which is the point when we will need to regenerate the content. So, for example, if something change in the data, if we have a car list and the user, for example, modifies some properties of the cars, for example, would like to change the name of the car, then our previous rendered content will be outdated. So it will be outdated, so we will need to regenerate the content on the server side, cache it again, send to the client side. So we won't implement this change mechanism today because we don't have an API here, but the caching, we will check out the caching. So this is the incremental static regeneration. So regularly you will need to regenerate the content, and for example, this is one case that the API server will invalidate your cache because data is changing, and until the data is changing, you are fine with the previously rendered content, so everything is fine. This is a very effective solution. We are using it in real life situations, and I think that's the best today that you can use in this area, in the rendering solutions area. Okay, so let's get started. We will implement the caching solution here. Okay, so let's check out that how is this SSR application working in our browser. So if I run the application with the npm run server command, then we can open our application on the localhost 3009. Here we can see if I refresh the application, then in the first call, in the first request, we get back the whole HTML content. So the server-side rendering is working, and here you can see that the main.js is included here, but if I check the loaded JavaScript files here, then we can see here that the cars is loaded dynamically. Okay, so let's improve this application with the caching mechanism. For this one, we will install the memory cache npm module. So first install it. Okay. Okay, it's done. Now I'm importing the memory cache, so import memory cache from memory cache. Okay, and here we have the server-side rendering. Okay, the next thing is that somehow we should get the rendered HTML. This mechanism sending the rendered HTML through a pipeable stream to the client, and here you cannot see that where we can get the HTML. For this purpose we will use another stream. We will call it content stream, and let's declare stream content streamed. Let streamed content equal 0. This is a string. This will contain our rendered HTML, and we have a stream for this purpose. Call it content stream. Okay, import the transform. This is coming from the stream package, and here we have this one. Sorry, this is Windows. Okay. We can call transform, and we have the chunk, the encoding, and a callback. Yeah. Okay, and here we can concatenate the actual chunk to the streamed content. So we can write streamed content is equal chunk that to string. Okay, and this push chunk. Okay, and we call the callback. Okay, the content stream is ready to use, and first we have this on share ready, and here we pipe our content stream as well. So pipe content stream. With this one we piped our content stream before the original pipe is and the other thing that we need to do is that we have a callback function on the content stream, the finish function. Okay, before we are writing the onFinish function, we just need to modify a little bit on our React application. We don't want to deal with lazy loading, so just using the import directly, because I would like to simplify a little bit this tutorial. Okay, we are building the client again because we modified the code. Okay, it's ready. Now just start the server-side application. Okay, so here you can see that the rendered content, let's check it here rather than, so the rendered content is inside of this mark and this mark. So we can write the function, the finish function of the content stream, and save the rendered content into memory cache. Content stream that on finish. Okay. And here we have, if we haven't generated the page yet and not found in cache, then we generate it. We have the start index, which is stream content index of, and we need this mark. And also we have the end index. And this mark. Okay, and we have the HTML, which is streamed content, substring, start index and index. And the cache data will be an object where we put in the HTML. Later you can put in, for example, the data which is coming from the API. You can cache it as well. And we put this into the memory cache. Request base URL, JSON, stringify, cached data. Okay, try it out. Console log the cached content. After the second call, we have to see the cached content. First call, now the caching is done, maybe, and now I am calling again. And here we can see the HTML. Okay, this mark is there, but now we don't care about it. You can write a clever substring method. Now it doesn't matter, so we have the cached content in our cache. Now the next step is to check if we have cached content, then serve the client with it, and we don't need to re-render the application. So we need to modify our app SSR component. Here I introduce a new prop named cached HTML. This cached HTML is a string. Sorry. Okay, and if we have a cached HTML, then so here, if we don't have the cached HTML, then we are rendering the application component. If we have the cached HTML, then we put this div here, and we are setting the inner HTML HTML with the cached HTML. So I wanted to do this here. Yeah. So div root, and in our server.js, before this one we are checking, put this one here, if page from cache. Here we console log that. Okay, serve this URL from cache, and we destructure the HTML from the page from cache. declare this cached HTML here. Okay, and we send this inside here. Okay, try it out. We can remove this console log. Sorry, one more thing. We need to build our client just to make sure that both the client and server side code match to each other. And we will see that in the first call we won't have a cache, so we won't see this console log. But in the second call we will see this console log here on the server side console log. Okay, it's running. One, two. Here we go. Okay, it's good. This route is another other route. So this one is the first route, which is this component, this root div, and inside of our cars component we have another div with named root. So this is another one, so everything works as everything works properly. And now we have the caching mechanism. To make it a full incremental static regeneration, you need to deal with the caching clearer mechanism. I recommend you, if you have an API and the data is changing, during the server-side rendering, when you are fetching the data, the API should tell your application that you have to drop the cache, then you remove the cached content from the cache and you regenerate it again. And after that, you will have an incremental static generation method. Okay, thank you very much for watching. If you like this video, please press the like button, and if you would like to support me, then you can find the thank you button under my video as well. Don't forget to subscribe. You will find many interesting tutorials on this channel in the future as well. Thank you very much again. Have a nice day and bye.